Today we're going to graph a demand line, and we're going to look at what happens to the price elasticity of demand along a straight line demand curve. And we're going to be looking for some patterns here. Let's graph this demand line, and then we're going to review the midpoint formula for calculating elasticities. And then we're going to calculate elasticities at all the points along this demand line. So here's our demand for the day. Price equals 12 minus 2q. And so that tells us that the y-intercept is here at 12. And of course, we put price on the y-axis and quantity on the x-axis down here. And that slope of minus 2 tells us that every time we go over 1 or increase q by 1, we're going down 2. So we're going over 1 and down 2, over 1, down 2, over 1, down 2, etc. And then we just want to connect those with a straight line. Okay, so there is our demand line. Call it a demand curve, but it's a straight line. And what we're talking about today are what are the characteristics of price elasticity of demand, or responsiveness as measured as an elasticity, if we're analyzing a straight line demand curve. So let's review the formula we're going to be using, the midpoint formula for calculating percentage changes. So price elasticity of demand is, just like all elasticities, a percentage change over a percentage change. And in this case, the price, since that's the first word, or the cause, the percentage change in price goes in the bottom of this formula in the denominator, and the percentage change in quantity goes in the numerator. Now, the midpoint formula is our special way of calculating percentage changes when we're looking at elasticities. The midpoint formula says to take how much something is changing and divide it by the average of the two values. Let's look at the first 2 points along the demand curve. So starting at the very top, let's call this point A here, and go to point B. So if we were to start at the top of this demand function when the price is 12 and the quantity is 0, and lower our price from $12 to $10, we would see the quantity go from 0 to 1. Okay? So the two prices we're talking about are $12 and $10, and the two quantities are 0 and 1 unit. So let's calculate the price elasticity of demand. Let's just fill in the blanks over here. In the top, we want the change in the quantity. So the change in the quantity, we're going from 0 to 1, remember? So the change in the quantity is plus 1. So let's fill in the blanks here. So that's going to be plus 1, change in quantity. What's the average of those two quantities that we're moving in between, 0 and 1? This is why we call it the midpoint formula. What's the midpoint between 0 and 1 unit? A half. So it's the average. 0 plus 1 is 1, divided by 2 is a half. So we have plus 1 on the top, divided by a half on the bottom, and then we multiply that times 100, and that's going to give us the percentage change in quantity using this midpoint formula. 1 divided by 0.5 is 2, times 100 is 200%, is what this formula is giving us. So it's a 200% change in quantity. But now we need to get that percent change in price. So the procedure is exactly the same kind of thing. The change in price, we're moving from a price of 12 down to a price of 10. So what's the change in price going from $12 down to $10? We're going down 2 is the change. Down 2. So we're going to call that a minus 2. And then on the bottom, we want to put the average of the two prices. What's the average of $12 and $10? 11, right? It's the midpoint. It's the number exactly in between 12 and 10. You can always average them in the conventional way if you want. 12 plus 10 is 22, divided by 2 gives you 11. And then we're going to multiply that times 100 to make it into a percentage, right? What we get here is 18.2%. So 18.2% change in price. So 18.2%, but that's a negative 18.2% because the price was going down. We don't want to forget about that minus sign on the 2 there. So this is going to give us a very large elasticity. We can see that even before we calculate it, that the top is bigger than the bottom. So this is going to be an elasticity whose absolute value is larger than 1, so we're going to call it elastic. So what do you get when you take 200 divided by a negative 18.2? We get an elasticity of about minus 11. So equals minus 11. So the elasticity is negative, as price elasticity of demand always is, although it could be 0, but never positive. So as we have discussed before, sometimes economists would just write that as an elasticity of 11, since we know it has to be negative when we're talking about price elasticity of demand. Okay, so let's label our graph here with the elasticity. I'll use a little e here. E equals minus 11. So we're very elastic between these first 2 points. Now let's go between the next 2 points, and let's practice this again. So let's go between point B and point C on the line, and let's calculate the elasticity there. All right, so what's happening? Let's fill in the blanks here. What's the change in quantity as we go between B and C? Well, we're going from a quantity of 1 to 2. What's the change in quantity there? Well, it's 1 again. And that's because we're moving along a straight line. What we're doing is we kind of step along this line as we're increasing the quantity by 1 each time, right? So we're increasing the quantity by 1. What's the average quantity between 1 and 2? 1 plus 2 is 3. 3 divided by 2 is 1.5. All right, so 1.5. Multiply that times 100. And we're going to get a 66.66666% change, or we could round that off as maybe 66.7%. And that's positive because the quantity is increasing. So it's an increase of 66.7%. Now let's do the same thing with price. When we go between B and C, the price is going from 10 to 8. So what's the change in price down here? Well, the change in price is again minus 2. Since it's a straight line, whenever we increase the quantity by 1, the price has got to go down by 2. But what changes here is the average price we're talking about. What's the average price between 10 and 8? What's the midpoint? We can see it here on the graph. It's 9. So 9. Multiply that times 100. 2 divided by 9 times 100 gives us a decrease of 22.2%. So minus 22.2222 running percent. And so what's our elasticity? Well, if we hadn't rounded that, right, this is 66.666666. On the bottom, 22.2 running, that's going to be 3 equals minus 3 is our elasticity. Let's label that over here on the graph. So already with looking at 2 different sections of this straight line demand curve, we start to see something of a pattern that's going to continue. What's the pattern that you see? That even though we're still having elasticity whose absolute value is bigger than 1, it's getting to be a smaller number. We're getting less elastic, right? 11 is very elastic. That tells us for each 1% change in the price, we're going to have an 11 times as big, an 11% change in the quantity. But here, it's only 3% change in the quantity for every 1% change in price. That's still pretty responsive, but not as big as the 11 that we had before. All right, let's do one more together, and then I'm going to beg you to stop the video and do the rest of these yourself, or pause the video. All right, so elasticity equals, let's go between points C and D. And let's fill in the blanks here. So when we go between points C and D, the change in quantity is from 2 to 3. So as we've seen this familiar pattern, since we're working along the same line, quantity is going up by 1. The average quantity is changing, though. Between 2 and 3, the average of 2 and 3 is 2.5, the midpoint. Multiply that times 100. 1 divided by 2.5 times 100 tells us that this is a 40% change in quantity. Again, that's positive since we're increasing the quantity when we move between C and D. And now the percent change in price. So when we go from C to D, we're lowering the price again by 2, going from 8 down to 6. Now, of course, this is not always going to be the case for every line, right? It's going to depend on the slope. But in this case, since we're dealing with this line, the price is going down 2. And then what's the average price between C and D? $8 and $6. The midpoint, or the average, is 7. So minus 2 divided by 7 times 100. And let's see what we get there. We get minus 28.57% change in price. So, to get the elasticity, we divide the percent change in quantity by the percent change in price, and we see what we get. And I'm getting an elasticity of about minus 1.4. Minus 1.4. So let's label that on our graph. Okay, again, please, if you want to have any hope of understanding how to do elasticities, press pause on the video right now. Get a sheet of paper and a calculator. And I want you to do these last sections here between D and E. Let's zoom in here so you can see what we're talking about. And if you don't have this handout, download it, print it out so that you can do this along with us. So go between D and E and E and F and G and calculate these remaining 3 elasticities for this orange section here between D and E, this green section between E and F, and this purple section between F and G, okay? So I'm going to move this back over here so you can see the formulas and see what we did before. Pause the video and work out those remaining elasticities, and I'll come back and show you my answers. All right, so here are the answers that we get as we continue down the line, as we go from a quantity of 2 to 3, 3 to 4, 4 to 5, and 5 to 6, down to the end of this line. Here I've calculated the percent change in quantity, percent change in price over here on the right, and then doing the ratio of those two so that you can see what my answers for the percentage changes were. And here are our elasticities. We see that as we keep going down the line, the price elasticity of demand becomes a smaller and smaller and smaller number in absolute value. It's getting more and more and more inelastic. Now, why is this happening? Well, let's label it along the line, and then we can kind of think about this. So here we have our elasticity of minus 0.71 between E and F, minus 0.33, and between F and G, minus 0.09. What's happening here is that as we go down the line, our change in price is always going down 2, and our change in quantity is always going up 1 since it's a straight line, right? That over 1 down 2 is the minus 2 slope of this line that we're working with. But what's changing are the percentages, right? Those midpoint values that go on the bottom. The average quantity goes from 2.5 to 3.5 to 4.5 to 5.5. So that's becoming a smaller and smaller percentage change in quantity. And what's happening to the percentage change in price? Well, we still have that minus 2 everywhere on the numerator, but in the denominator, we see the midpoint of the price is going down as we go down this line, from 7 to 5 to 3 to 1. So the percent change in quantity we see getting smaller and smaller and smaller. The percentage change in price is getting larger and larger and larger, about 29%, 40%, 66%, 200%. So the way we're calculating this, since it's percentage change divided by percentage change, the numerator is getting smaller, the denominator is getting larger, we're getting more and more inelastic as we go down this demand line. Now let me mention something about calculating elasticities here. Let's go back over to the ones we were calculating before. Normally, I like to calculate this as a percentage change over a percentage change because that, after all, is what the formula is for the price elasticity of demand, and all elasticities are a percentage change over a percentage change. However, many of you might have noticed that since we're multiplying the top of a fraction by 100 to get the percentage change, and the bottom by 100 to get a percentage change, we could, if we wanted to calculate elasticities more quickly, just do away with that part, right? We could just cancel that. And if all we want to do is calculate an elasticity, we could save ourselves some time by just skipping that multiplying by 100 part, because it's going to cancel anyway when we do this ratio. So what we would end up with for this first one, just to give you an idea, if we did that, instead of ending up with a percent, we'd have kind of a proportionate change. If we don't multiply that by 100, we'd end up with 2 instead of 200% on the top. And on the bottom, if we didn't multiply that by 100, we'd end up with 0.182. And when you divide 200 divided by 0.182, you're going to end up with minus 11 anyway. So this is just a little simplification you can do if you want to be able to calculate elasticities quickly. So the kind of elasticities we're calculating here using 2 points, 2 prices, and 2 quantities, we'll often call this kind of elasticity an arc elasticity. Arc, A-R-C, elasticity. Because we're going along 2 points along a curve. Yeah, this is a straight line that we're looking at right now in an introductory economics class. Usually that's what you'll stick with. But we could do this same kind of procedure along a kind of curved demand curve, and then we'd be looking at 2 points along an arc here, right? So we call this kind of elasticity an arc elasticity when we're going between 2 points. There's another way. There's another formula that you may see in some textbooks or some research papers about calculating price elasticity of demand, or indeed any elasticity, and you can do it at a point. As long as you know the slope of the demand line or the slope of the relationship that you're looking at, you only need to know one price and one quantity. And I bring this up because I want to ask you first a question just to see what you think, and then we're going to show that this is actually true. Looking at this demand line here, we see this pattern where we have large elasticity, smaller, 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 smaller. Suppose we wanted to know where the price elasticity of demand was equal to 1. And we'll find out why that's important in just a second. But if you had to guess, looking at all these elasticities between A and B, it's minus 11. Between D and E, it's minus 0.71. If you had to guess, where would the price elasticity of demand be exactly equal to minus 1? Now, if you guessed, here the elasticity is minus 1.4 between C and D. Here between D and E, the elasticity is minus 0.71. If you guessed, well, it might make sense that the price elasticity of demand right there is about minus 1. You'd be right. Now let's demonstrate that, and then let's talk about why that matters. So let me share with you another formula quickly that can be useful for calculating elasticities. And this is called the point elasticity formula. Point elasticity says we can calculate elasticity of demand this way. Take 1 over the slope of your demand curve times the price you're interested in divided by the quantity that you're interested in. This way you don't need 2 prices and 2 quantities. As long as you know the slope of the relationship you're looking at, you can calculate an elasticity. Let's use this formula just once to see how it works, and let's use it on this point right here, this point D, where we suspect the elasticity might be minus 1. Let's plug in what we know. The slope of this demand curve, remember, was minus 2. So the elasticity equals 1 over minus 2 times the price there is $6, and the quantity is 3. So it's minus 1/2 times 6 over 3, which is 2. And sure enough, our elasticity right there at that point is -1. So that's an interesting thing. Let me teach you a general relationship here. In general, if you look at that halfway point, right, that's what that point D is. The y-intercept is $12. $6 is exactly halfway down the line. The x-intercept on the quantity axis down here is 6. That point D is halfway over between a quantity of 0 and a quantity of 6. It turns out for any demand curve that is a straight line, we see a pattern that above that midpoint, so up here on the top, the elasticity is always going to be elastic. The absolute value will always be greater than 1 on the top half. The elasticity will always be less than 1 on the bottom half. And the elasticity will always be exactly equal to 1 right in the middle. Now, why would we care where the elasticity equals 1? Well, it turns out that point is important for a lot of reasons. Let's show you one really important one right now. Let's calculate the total revenue at each of these points. So let's suppose that we were a business and we hired a company to figure out what our demand looked like for our product. And we wanted to know, okay, if we could choose any price we wanted to, let's look at the impact of the price we charge on the total revenue coming in, the price times quantity. So let's calculate total revenue at each of these points. So point A, price times quantity. Well, price at point A is $12 times, well, we would sell no units, right? So our total revenue would be $0 there. Let's move to point B. The price at point B is $10. The quantity is 1 unit. So the total revenue, 1 times 10, would be $10. All right. Total revenue at C, well, price is 8, quantity is 2, total revenue, $16 at point C. What about this point D, where the price elasticity of demand is equal to -1? The price is $6, the quantity is 3 units. Total revenue there would be $18. How about here at point E? The price would be $4, the quantity would be $4, total revenue, 16. Aha, now you're starting to see something. Total revenue at point F would be 2 times 5, or $10. Total revenue at G, if we gave these products away for free, we could give away 6 of them, but charging $0 per unit is going to leave us with no revenue. So here's where that point in the middle is important. The total revenue is as high as it can be, where the price elasticity is equal to -1, and if the demand is a straight line, we know where that is. It's exactly in the middle. So this lesson that we've just learned, the relationship between elasticity and total revenue, is one that's very important. And if you practice this just a couple of times and think about it, it's not that hard to remember. So somebody could walk in. Let's just graph a random looking demand over here. So here somebody walks in and shows you a demand curve, and it looks like this. And the y-intercept is $800, and the quantity intercept is 500 units. And somebody asks you, quick, tell me, where's the price elasticity of demand equal to -1? And also, I need you to tell me where the total revenue would be maximized. You can say, I don't need any time to do this. I can tell you right now. Right there in the middle, we go halfway down to a price of $400. We go halfway over from a quantity of 0 to 500. That's 250 units. That is where our total revenue is maximized. And all we have to do is put that in our calculator, $400 times 250 units. And we can tell you that the maximum total revenue is $100,000. Price times quantity. And people will be amazed. How did you do that? Well, Dr. Berkey taught me how to do that. And we can verify this, if we wanted to, using that point elasticity formula here. All we'd have to do is figure out the slope of that demand line. 1 over the slope times price over quantity. 1 over the slope times 400 over 250. And we can verify that the price elasticity of demand is -1 right at that point. Check it out if you don't believe me. We can also say from this that up here, the elasticity is going to be greater than 1 in absolute value, right? So we're going to be elastic. And down here, the absolute value of the elasticity is going to be less than 1. And that brings us to the last topic for this lecture, and that's what we call the total revenue test. The total revenue test. The total revenue test says, suppose you have a business and you don't know what the price elasticity of demand is for your business. And you don't want to spend a lot of time changing your price, collecting a whole lot of data to figure it out, but you just need to know, right where I am, is the demand for my good elastic or inelastic or unit elastic? Is the elasticity equal to 1? The total revenue test says, change your price a little bit and see what happens to total revenue. So again, this kind of diagram, I know it's busy and junky and there's a whole lot going on here, but it's a whole lot that's going on that's important. The total revenue test says, if you raise your price and your total revenue increases. Now let's look at this relationship here. If I were to raise my price and my total revenue goes up, that must mean that we were in the bottom part down here, right? And this total revenue test works even if you're not talking about a straight line demand curve. So if you raise your price and your total revenue goes up, that must mean that you are in this inelastic part of a demand line or a demand curve. So if you raise your price, total revenue goes up, inelastic. But if you raise your price and your total revenue goes down, right? That's what happens up here. We are elastic. That means that you know if you raise your price and your total revenue goes down, that the demand for your product is elastic. It means that when you raise your price, the quantity is dropping faster. The percent change in quantity is larger than the percent change in price. And that means that demand is elastic. So basically, if you're moving toward where the elasticity equals 1, if you're raising your price going toward the middle, your total revenue is going up. If you lower your price going down toward the middle, your total revenue is going up. Otherwise, your total revenue is going down. And that's what we call the total revenue test for elasticity. If you raise your price and your total revenue goes down, elastic. If you raise your price and your total revenue goes up, inelastic. Well, I'm going to end this video here. If you have any questions, as always, please let me know. Otherwise, this is Dr. Berkey signing out. I wish you the best of luck getting a handle on elasticities.